So we have covered in class these 4 types of inheritance: complete dominance, incomplete dominance, codominance, sex-linked traits, and we've seen them in pedigrees. This is about what we've covered so far. So let's just do a practice problem for the first, complete dominance. I've outlined a way to do it with the steps I've taught in the last video, which was video 0. Okay, this is number 1, and here's the problem. In pepper plants, an allele for hot flavor is dominant to an allele for mild flavor. A farmer crosses a homozygous dominant plant with a recessive mild plant. What percentage of offspring from this cross will have a hot flavor? Okay, so step 0 is the setup, and it's this part and this part. Okay, this is the setup. What type of inheritance? So first thing you need to understand is, what are we looking at? What type of inheritance are we looking at? It's going to be critical to the problem. And it says right here, H is dominant to little h. So we know it's complete dominance. So we can circle that right there. It's really important to understand. Next, we're going to look at the possible genotypes, and we're going to write them out. Okay? And we know that this is an important one, and this is important. Okay? So this is your dominant, this is your recessive. So let's do homozygous dominant, heterozygous, different, right? Dominant and recessive. And then both recessive is homozygous recessive. Let's write those words. That way they go into our head and stay there. Homozygous, dominant. And if you write them, they're going to stick in your brain, right? So write them out. Heterozygous and homozygous recessive. Right? Okay, so you should really write those out each time until you become a master at these. Okay, now let's look at the phenotypes. So these are the genotypes. These are the genes. What trait do they give is the phenotype. Pheno means physical expression, right? HH is dominant. It's going to give a hot flavor. So we'll write hot. Little h, heterozygous, is still hot because the big H is dominant over the recessive. So you're still hot. And little h is recessive, so because it's homozygous recessive, there's nothing to block or mask it. It's going to be mild. Now, to make it clear later, we're going to circle. We're going to use a circle for these. Okay, so you could just do it twice, or you can make a big circle, but we're going to circle, and we're going to mark this with like an X star kind of thing. Okay, this is going to come in handy later. This is basically our key. Okay, so we've now set it up properly. Let's do the problem. Parental cross. So the first thing is to understand the parents. It's the most important step. And we have the farmer crosses a homozygous dominant with a recessive mild. Homozygous dominant. And we know it because we have a key. So we know we have this, right? HH, homozygous dominant, and a recessive mild. And we know this is recessive because we made a key. And you can see how important it is to know these words, because often the problems become word problems and you need to know the vocabulary. So we have the parental cross because we know the vocabulary. Alright, let's do the Punnett square. That is the next step. We don't do the Punnett square until we have the proper cross, right? That's really important. So let's do the Punnett square. First, pretty easy, you make a square, right? And then I like to put this one on this side. It does not matter. You could put this one here if you wanted, but we're going to go like this and like that. Now the bigger H usually is always going on the left side, so you wouldn't write it like that. You would write it like that if you had a decision. This is the way. This is the standard way, conventional way. Okay. Bring that H there, and then bring this H here. Bring this H here. Right? You guys see that? Okay. And here. Right? So we have the genotypes. Now let's find the phenotypes with our special key. So we're going to look, do we have any HH, homozygous dominant? No. Okay. Do we have any heterozygous? Looks like we have all heterozygous, so let's circle each one. Do we have any heterozygous recessive? No. Okay. So that's step 2. Now step 3 is we write the genotypes, and we just do the same thing. We've already, because we have the key, we've already kind of done this, but you want to redo it because it's good practice. Okay, what's the ratio? All we have to do is count now. This one, anything that's circled, well, we have to actually look because we have a circle for both. But do we have any big H? No. 0. Do we have any heterozygous? We have 4. And do we have any homozygous? 0. 100% heterozygous. Phenotypes. There's only 2 in this, right? Because it's dominant. So we have hot and mild. Notice these will both give hot, and this will give mild. What's the ratio? Okay, so we have how many hot? How many hot? We have 4. How many mild? We have 0. So 100% hot. That's your answer. So what percentage of offspring will have a mild flavor? We'll have a hot flavor. 100% will be hot. And that's how we do it. But we haven't finished yet, have we? Because we have to check, and when we check, we go backwards. Did we count the genotypes and phenotypes correctly? Okay? So I have 4 heterozygous, and I see 4. Counted that. I have 4 hot. 4 circles, right? 4 hot, because we marked hot with a circle. Correct. So that's correct. Genotype and phenotype are correct. Did we do the Punnett square circles and dots correctly? So we said that this was going to be a circle for heterozygous, and they're all circled, so correct. So we labeled all these correctly hot. Did you fill out a Punnett square with alleles correctly? So did you put the H in the proper place? So these are all big H and then little h, so yes, correct. And most importantly, did we check the parents? So let's take a look at the parents. The way you do this is describe them with your words and then see if it matches the word problem. So first, without looking at the word problem, this is a homozygous dominant. All dominant, hot, homo recessive, which would be mild. So let's look at the word problem. We have a homozygous dominant with a recessive. Homozygous dominant with a recessive. We should have the right parents. That's how you do it.